Molar mass is calculated with the same setup as we used in the video for formula mass. We add together the masses of all the atoms in the molecule. The contribution from each element is shown in the equation. There are two differences, however, compared to formula mass. One, formula mass is the mass of one molecule, whereas molar mass is the mass of 1 mole of molecules. Two, the units of formula mass are unified atomic mass units, U, whereas the units for molar mass are grams per mole. To summarize, molar mass is the mass of 1 mole and has units of grams per mole. We will get the same value for these two calculations, although the values are not identical. With the 2019 redefinition of the mole, there is now an uncertainty between the values of formula mass and molar mass of 4.5 times 10 to the negative 10. But for calculations done in a chemistry class, within the few decimal places shown on the periodic table, we can say that the values are the same. The molar masses we'll need for this problem are magnesium, 24.305, phosphorus, 30.974, and oxygen, 15.999. To set up the problem, we write 3 times the mass of magnesium, 24.305, plus 2 times the mass of phosphorus, 30.974, plus 8 times the mass of oxygen, 15.999. Remember that both subscripts are multipliers. The 2, which is outside the parentheses, applies to everything inside. Since the oxygen already has a subscript, we need to multiply them together to get 8 oxygen atoms. When we do the calculation, being sure to use the parentheses in the calculator, we get 262.855. For the sig figs, notice that all 3 of the molar masses have 3 decimal places. So the final result will also be rounded to 3 decimal places. It turns out that the value from our calculator has the correct number of sig figs. So our final answer for this problem is 262.855, and the units are grams per mole.